Hi kids. Let's see the next one. Coulomb's force for multiple charges, or the superposition theorem, or we can say collection of point charges also. So the other name, Coulomb's force for multiple charges, or the superposition theorem, or collection of point charges. When we have multiple charges, what happens? How can we apply the Coulomb's force? This is what. When we have two charges, we know very well the F value is Q1, Q2, K into Q1, Q2 divided by R square. But when we are having more than two charges, what happens? How to find out? So the best theorem or the exact theorem what we are using to find out the net force acting on a particular charge when we have more than two charges is known as superposition theorem. So according to superposition theorem, the total force acting on a given charge, any particular charge, the given charge is equal to the vector sum of forces exerted on it by all the other charges. I repeat, according to superposition theorem, the total force acting on a given charge, is equal to the vector sum of forces exerted on it by all the other charges. Whatever may be the number of charges, more than 2, if it is exerts in a particular medium, then the force exerted on a particular charge will be sum of all the individual forces. This is what superposition theorem states. And we know very well between the two charges, the F electrostatic force is equivalent to K into Q1, Q2 divided by R square into R cap. This is general formula, right? And here I took 4 charges, Q1, Q2, Q3 and Q4. You can draw it in any manner. I took Q1, Q2, Q3 and Q4. All the other 3 charges acts on Q1. So what is the distance between Q1 and Q2 is R21. Q1 and Q3 is R31. Q1 and Q4 is R41. We should know the distance because inversely proportional to R square, the distance. So I took the distance like R21, R31 and R41. Between 1 and 2, R21. Between 1 and 3, R31. Between 1 and 4, R41. And the force experienced by Q1 I am going to find out. Which charge I took as a common charge is Q1. So what is the force acts on Q1 because of the existence of the Q2 is F12. Q2 acts on Q1 which is nothing but F12 vector. Q3 acts on Q1 which is nothing but F13 vector. Q4 acts on Q1 which is nothing but F14 vector. On which one I took? Q1. So here F12 vector, F13 vector and F14 vector. So I took Q1 as a common point and I am taking the net force acting on the charge Q1. Let's see what are all the force it experiences. The first one is between Q1 and Q2 which is nothing but F12, Q1 and Q2 between. So what is the value? K into Q1 into Q2 divided by R21 square into R21 cap. Between 1 and 2. So between 1 and 2 is Q1 and Q2. And what is the distance? R21. Here what is the distance? R21. So R21 square into R21 cap. Similarly between 1 and 3 it is F13. K into Q1 Q3 divided by R31 square into R31 cap. Between 1 and 4 it is F14 vector is equivalent to K into Q1 Q4 divided by R41 square into R41 cap. 2 charge and the distance between, that's all. 2 charge Q1 Q2, Q1 Q3, Q1 Q4 and the distance. So we got now individual force value acts on the Q1 because of Q2, because of Q3 and because of Q4. So these are all the 3 forces acts on the charge Q1. What are all they? F12 vector, F13 vector and F14 vector. We have to find out the net force act on the charged particle Q1. So net force is nothing but add the individual force value. So the F net is equivalent to F12 vector, F13 vector and F14 vector. Substitute all the three values, take which is common. K remains a common value which is constant on Q1. So everywhere I am having what? Q1, Q1, Q1. So I took Q1 also. So K into Q1 into first charge Q2, second charge Q3, third charge Q4. All these three charges are acting or exerting the force on Q1. Q1 experiences the force. So taking the Q1 and K common, so K into Q1, it is sum of. So sum of I value, which is a variable which varies from 2 to 4. I am not taking 1 here. Why I am not taking 1? Because all the other charges acts on Q1. So Q1 is a common one. So it starts from the next charge value, which is nothing but 2. Here I took totally 4. So 2 to 4, Qi, 2 varies, 3 variable, 4 variable, it just keep on varying. So I is a variable which varies like 2, 3, 4. So Qi divided by Ri1 square into Ri1 cap. I is a variable which varies from 2 to 4 and 1 remains common because all the forces, all the charges exerts the force on Q1. Q1 is the only charge which experiences the force. The next one, for n value, here I took only 4 charge, so it's okay. If I am taking n number of charges, then F net is equivalent to KQ1 into sum of I varies from 2 to n. I am taking n number of charges. So I varies from 2 to n, Qi divided by Ri1 square into Ri1 cap. It is not that we have to take always Q1 as a common point, common charge. You can take anything. Thank you.